Good morning, good afternoon. Let's get started by logging into Clever. All right, here's your warm up. If you could eat one food for the rest of your life, what would it be? I think mine might be tacos because there's so many different ways that you can make tacos. So there could be a lot of variety. All right, so welcome to week 9, live lesson 17. We're talking today about the subatomic particles and how they differ between elements, and then how we can use the periodic table to give us information about these elements, these atoms, and these subatomic particles. So some reminders, I usually really get updating on grades on Sundays and Mondays. So you might have gotten a lot of notifications about returned assignments or missing work or about grades being put in. So use that information to kind of guide you with what you need to be working on. Make sure you're checking comments if you thought something was done and I didn't think it was done, or it wasn't done to the quality or level that I need it to be. Please make sure you're checking that. Also check Edpuzzle for any not only comments, because I don't know if you realize that, but like I comment on a lot of your answers, but also to make sure that you have viewed it all the way through and that it has been submitted correctly so that the grade uploads. Remember that I want you in the live class if you can be, because it is a chance for me to interact with you, to see live and right then how you're doing with our content and the information. Please make sure that you get into those classes in a timely manner, that you have all of the links and things open that you need to, and that you're being a safe, responsible, respectful, prepared, and here student. I will say I noticed that a lot of students really pushed hard before the end of the 6 weeks to get your grades caught back up. And now it seems like the last week we just kind of relaxed too much. And so now people are getting behind again. Don't get caught, don't get behind, stay caught up, stay on top of things, and keep pushing forward. Okay. As always, thank you guys for being here. Thanks for giving me your best effort and for showing up every day. Let's rock this. So this week we're talking about how the atom is structured. We're thinking about simple atoms and what those look like. What are the subatomic particles and what do they contribute to the atom? And then how does the periodic table give us information about all of these things? So today we are going to be doing some work with the parts of the atom. And then after you finish up watching this, you're going to be able to successfully complete 2 assignments: the number 38 Colorado PhET Build an Atom, and number 39 reflection question: are atoms indivisible? All right, so we're talking about periodicity. We're talking about the elements that make up matter, and what is matter, and what are atoms, and all of these things that make up everything and allow us to exist. So let's start with this. Please do not just copy and paste a definition from Google. I will mark it as incorrect because it is real obvious. In your own words, based on what we talked about last week, based off of the work that you did with looking at the history of the atom, define the atom in your own words. Awesome. So an atom is a single small particle that describes and that is the simplest form of an element. And so we're going to be looking at the structure of the atom and looking at what that means and these definitions and these simple terms. And so what I've done for you, if you're somebody that likes to write notes, or if you think that that's a good thing for you to have for yourself, all you need to do is open this link. It will make you a copy of some very basic structured notes for you to fill in, follow along with the major important information that we're getting from today's lesson. All right. So if we remember, we talked about Democritus and Dalton last week, and they both theorized, and then Dalton proved the presence of something that they called an atom, or atomos for Democritus, which is the smallest particle of an element that still has the properties of that element and that cannot be divided anymore. That it is the smallest it will get. It is the smallest particle of matter. It is an important fundamental piece of all matter. Now, they're not entirely wrong, because an atom is super important, and an atom is the smallest particle that still has the properties of whatever element it is. But there were some scientists that came through and said, nope, there's actually some smaller particles, which we call the subatomic particles. So over the course of about 150 years, these men were able to discover the 3 major pieces to our atomic theory. And all of this had to do with the elements. So elements is a substance that cannot be split into anything simpler by a chemical change. It can be split through a nuclear change or changed through fusion or fission, but not a chemical change. And we're going to spend a lot of time thinking about elements, particularly the periodic table of elements, which is a way to organize all of the elements that are found either naturally or man-made or whatever. Now, the atom, as Democritus and Dalton described it, is the smallest particle of an element that still has properties of that element. And that is true. That is true. Now, their part about it being indivisible and that it is there is nothing smaller than it, that is the part that we have problems with. Now, the atom has two major areas. One is the nucleus, which is the center of the atom, where protons and neutrons are found. The shells, which you might also call the clouds, the levels, the orbits, the orbitals, the energy levels, that is where the electrons exist, okay? And again, the nucleus is not the middle of a cell where the chromosomes are found. That's talking about biology, and if that's the definition you're putting, that means you're just Googling it. You're not paying attention to all of the things we're talking about. So we have these parts of the atom, okay? We have these parts of the atom. The nucleus is where you can find the protons and the neutrons. The electrons are in those shells or orbitals or clouds. And so this is an important chart to make sure that you are feeling really good about. The protons, okay, you'll see them signified as P, that makes sense, proton, and then with a little plus up to the right. And what that signifies is the charge of a proton. Protons are positively charged. They have a positive charge. They contribute a positive charge to the atom. They also contribute to the mass. So the atom, each atom, although it is teeny tiny, it does have a mass. And the proton is one of the important things that contributes to the mass. It is found in the nucleus, so it contributes to the mass of the nucleus. It contributes to the charge of the nucleus. And the protons are really important because they are what determine what element an atom is going to be. So a proton, if something has 6 protons, that means that that atom is a carbon, is the element carbon. If it has 1 proton, that means you're talking about an atom of hydrogen, because all the hydrogen element has, all of them will have, no matter what other forms it might be in, have 1 proton. The other thing found in the nucleus is the neutron. It is symbolized with an N, neutron, and it's 0. And that's the key thing, is a lot of people like to think neutron is negative. Nope, a neutron is neutral. It has no charge. That 0 there is important. It does contribute to the mass, though. So the protons and the neutrons will add together to tell you the total mass of the atom. And that's going to be important for us moving forward this week with our with being able to calculate these subatomic particles. Electrons are negatively charged. So the symbol again is an E with a negative. That's because it is negatively charged. Now that negative charge is super important. However, the electrons are really, really, really small. They are so small that they really don't even contribute to the mass. So that's why I said the protons and the neutrons will add together to tell you the mass of the atom. The electrons have nothing to do with the mass. They only have to do with the charge. And they are found in mostly empty space out in these shells or orbits. All right, so let's remember, where are the parts of the atom? Can we recall? Right, so our electrons go in the shells, so in those outer rings. Our protons and neutrons are in the middle. Our nucleus is that middle gray circle. And then the electron shells are those rings on the outside. So now, what charge does the nucleus have? If you pay attention to this image, it should be pretty clear. Right, so the nucleus has protons that have a positive charge and neutrons that have no charge. So the overall charge of the nucleus is positive. And where is most of the mass? Again, we got to remember, the protons have a mass, the neutrons have a mass. The electrons don't have any mass. So most of the mass in an atom is going to be right there in the middle in that nucleus. Now, the periodic table of elements is a way that all of the elements are organized based on some properties, based on some trends and some characteristics. On the periodic table, you're going to get really comfortable hopefully using this. Each element has a box that provides some information about it. So In that box, you'll see the atomic number. The atomic number is usually going to be either in the top left corner or in the middle on the top. And that is every element has a different atomic number. All carbon, the carbon element, all of the atoms or isotopes or ions or anything that is a carbon will have an atomic number of 6 because that describes the number of protons in it. And the number of protons are what make elements different from each other. The element symbol will usually be right smack dab in the middle. It's going to be 1 or 2 letters. The first letter will always be capitalized. The second letter, if it has one, will not be. The element name is below that. So carbon has an element symbol of C. Its name is carbon. And then below that is the atomic mass. So like I was saying, is carbon can come in many different forms. All of the carbons will have 6 protons, but some of the other parts of it might be a little bit different. What the atomic mass describes is the average mass of all of the other different types of carbon that might pop up. And so in this case, the atomic mass is 12.011, which next week next lesson, we're going to talk about how you would just round that to 12 to tell you to tell you the overall mass of the atom. All right, so can we remember this? Where do I find this information? Awesome. So up here at the top, that is your atomic number, number 17. The Cl is your atomic symbol. Chlorine is the element name. And then the mass is down here at the bottom. Great work. So what I need you guys to do is actually open up it's not 37, it's actually assignment number 38, where it says Build an Atom, Colorado PhET. Go and open that up on Google Classroom right now. So the document that you should have open is number 38, Colorado PhET, Build an Atom Basics. Okay, it will look something like this. I'm going to walk you through briefly how to do this assignment, or at least this first part, so that you can do the rest on your own. Okay, so we are going to go to this PhET. We're going to open up the Atom tab, and you want to make sure that all of these tabs are open to provide you as much information as possible, as well as checking all of these boxes. Now, the first instruction says after you have all of these open so that you can see everything, you're going to make an atom with 1 proton, 1 neutron, and 1 electron. So I'm going to grab one of these balls. I'm going to pull it in, remembering that protons won't go in the shells, but they will go into the nucleus. Okay, you notice that when I added that, what changed? It became an element with becoming hydrogen. It got a net charge of +1, and it had a mass of 1. And that makes sense because the proton has a positive charge and it has a mass of 1. All right, so if I go and I add my neutron, I notice that the charge didn't change, the element didn't change, but the mass number did because neutrons contribute to the mass. Next, I'm going to finish up with my electron. I add my electron. It will not go into the shell or into the nucleus. It will only go into the shell. And I noticed that the mass didn't change that time, but the net charge did. Also, it still is hydrogen. Nothing has changed there. So as you go through this, you're going to notice that adding the proton will change a lot of things. It will change what element it is. It will change its charge, and it will change its mass. Adding an electron will only mess with the charge. Okay? Adding a neutron will only mess with the mass. Okay? So you are going to be building some atoms, exploring how these 3 subatomic particles affect the different elements of the different parts of the atom. Okay? So to finish up, tell me, how did you like this lesson? Thank you very much. And I'm going to send you on your way. You have number 38, Colorado PhET, Build an Atom, where you're going to be using that simulation to fill in the document. That document will be telling you kind of what to do in the simulation. Then you have your number 39, reflection question. Are atoms indivisible, not invisible? And you're going to use the 5 sentence starters to provide structure for how you are going to answer that question. Alrighty, that's it for today. Have a great afternoon, evening, morning, whenever you're watching this. I will see you next time. Thank you for your time and your effort. Bye.